presently you can see on the screen. So this is R2R ladder network. So in this diagram you can see we are going to make the use of only two types of resistors. One is R, second one is 2R. Suppose if I take R equal to 10k and 2R should be 2 times of 10k, nothing but 20k. So therefore this type of digital to analog converter ladder type DAC, so it is going to make the use of only two types of resistors. One is nothing but R, second one is nothing but 2R. So this is nothing but the circuit diagram. So here A, B, C, D, these are nothing but the bits. So I am going to construct a 4-bit digital to analog converter by making the use of this ladder network. So that is in multi-sim simulation software. So starting from LSB, then MSB. So by changing the combination of these 4 bits, you can see what will be the output. So here you can see, so this is nothing but the number. So if I give 0, input is nothing but 0, that means all the 4 bits are set equal to 0. Then corresponding output should be equal to 0. When all the bits of the ladder type DAC are set equal to 0, output should be equal to 0. When input is a number 1, then that means A equal to 1, A is set equal to 1, the remaining 3 bits should be connected to ground, nothing but 0. So in this case, the output of ladder type DAC should be equal to 0.3125 volts. Similarly, if I give the number 2, input is nothing but 2, that is nothing but 0010. This is nothing but digital input 0010. The corresponding output should be 0.625. Similarly, if I give the input digit digital information, that is 0011, the corresponding output should be 0.9375. Similarly, if I give the digital input 0100, that should be producing 1.25 output voltage. So for 0101, the output should be 1.5625. For the digital input 0110, the output should be 1.875. For the digital input 0111, the corresponding output should be 2.1875. Similarly, for the digital input 1000, the corresponding output should be 2.5 analog voltage. So this is according to this formula. So here I have calculated the corresponding output voltage by making this formula. So where VR is nothing but the reference voltage. So most commonly the reference voltage will be selected as 5 volts. So depending on the combination of ABCD, you can find theoretically the corresponding output voltage of the DAC. So in this simulation experiment, so here also I'm going to construct a circuit by making the use of R2R ladder type DAC network. So in which I'm going to change the combinations of ABCD, then corresponding output voltage here I'm going to note. Then we will continue for the next one. So first of all, I'm going to construct the R2R ladder type DAC. For construction of R2R ladder type DAC, so I'm going to require two types of resistors. One is nothing but R, second one is nothing but 2R. So I'm going to select resistors R and 2R. So going to basics. So where I'm going to select resistor, the corresponding value is, for example, here I'm going to select R equal to 10k. So this is nothing but 10k. So this is the value of 10k R equal to. So if it is R equal to 10k, 2R should be 20k. Just wait. So another 10k, another 10k, another 10k. Then I'm going to select 2R value. So R we have selected as 10k. So 2R should be 20k. So this is nothing but 20k. So 20k. Another 20k. 20k. So this is nothing but 20k. Now I'm going to Write the circuit diagram. So this is nothing but LSB, nothing but A, capital A. This is nothing but B. This is nothing but C. This is nothing but D. So to change the ABCD value, either to set it to 0 or 1, I am going to select switches. No, here switches. So SPDT switch I am going to select. So this is one switch. Copy, paste, paste again. So 4 switches. So all these switches are connected to the corresponding 2R resistor values, as you can see in the figure in the circuit diagram. So to select 0 and 1, so 1 is nothing but plus 5 volts. So that's why I'm going to select a DC source. So this is nothing but the DC source. The corresponding value is 12 volts. Here I'm going to set this one as 5 volt. So 5 volts means it is logic 1. Ground. So to measure the output analog voltage, so here I'm going to connect this multimeter. So this is the multimeter. So here you can see, here key equal to space, key equal to space, key equal to space, key equal to space. That means if I press the space key through keyboard, then the status of these keys is going to be changing. You can see. So now I'm going to press this space bar. So you can see the status of all the 4 keys are going to be changing. So here I'm going to assign each key a different one. So here the key is uh, represented as capital A. So this is capital A. That means if I press capital A button in keyboard, the corresponding status of the key is going to be changing. You can see on the screen. So I am going to press A, the capital letter A, nothing but the letter A on the keyboard. Then the corresponding key is going to be changing. Similarly, I am going to assign capital B for the second key. So this is nothing but capital B. That means if I press capital B, the status of second key is going to be changing. Similarly, I am going to assign capital C for third key. I am going to assign capital D for fourth key. Okay. So depending on the status of nothing but depending on the input, sometimes you may be selecting 1 and B, C, D are set equal to 0, 0, 0. Sometimes suppose if I want to give the input, so 7, then A equal to B equal to C equal to 1 and D should be equal to 0. So depending on the A, B, C, D status, you have to press the corresponding keys through keyboard. Okay, so I'm going to select, I'm going to start from 0. So 0 mean all the four keys are connected to ground. Okay, if I want to give input 1, then capital A should be connected to 1, remaining are set equal to 0. So in this way, I'm going to change the input, digital input, then corresponding output. Here I'm going to note those values. So first of all, I'm going to give 0. That means all the keys are connected to ground. So here, all the keys are connected to ground. So go to simulate and run option. So here you can see the corresponding voltage value, that is 0. So here I am going to write the corresponding value as 0. Now I am going to select capital A equal to 1. Okay, remaining are set equal to 0. So capital A equal to 1 means I am going to press capital A key only. So I have pressed the capital A key. So this A, key number A is connected to battery positive of voltage 5 volts. That means this capital A is given logic 1, the remaining keys are given 0 0. So in this case, the corresponding output voltage you can see here. So it is 312.494 millivolts, nothing but 0.312. Okay, so here the corresponding voltage is 0.31249. So 49 I am going to write. Similarly, to give the input to the number 2, okay, to give the input number 2, so only key number B should be pressing and remaining should be open. Okay, so here B should be closed, so I'm going to close B while A is open. So only B is closed, remaining are open. Then you can write the corresponding output voltage. It is 624.987. That means 0.624. So here 0.624987, or you can write 0.6245. So in the second case, key number B and key number A and key number B both should be pressing. So already key number B is pressing, so you have to press key number A only. So I'm going to press key number A. So you can see A and B both are closed and remaining keys are open. The corresponding value you can see 0.937. Okay, so 0.937 4 something. So here it is very close. So similarly, for the next case, only C, but the bit C should be selected as 1. So to give C equal to 1, remaining key should be open. So A is open, B is open, C, the key C is pressed such that the key is connected to battery positive. So plus 5, C equal to plus 5, that means C equal to 1. So when C equal to 1, remaining are 0, so the corresponding voltage is 1.25. So here also we have 1.25. Then moving to the next one. So here A equal to 1, C equal to 1. So A equal to 1 plus capital A, capital A equal to 1, C equal to 1. Okay, so when A equal to 1, C equal to 1, then corresponding output voltage I can see it is running now 1.562. So 1.562. Then B equal to 1, C equal to 1. So B equal to 1, C is already set equal to 1, but A should be 0. So A is 0, B equal to 1, C equal to 1, and D equal to 0. So in this case, the corresponding output voltage is 1.875. So 1.875. So when ABC, when the starting 3 bits ABC are set equal to 1, so A equal to 1, B is already set equal to 1, C is already set equal to 1, D equal to 0, then corresponding output voltage is 2.187. So note the value 2.187. Similarly, when D equal to 1, remaining are 0. So when D equal to 1, remaining are 0. Okay, then corresponding voltage is 2.5. So these are the readings which are calculated by using this formula, and these are the values which are experimentally calculated by using R2R ladder network. So you can see, as per theory and as per experimental data, so we are going to get the same readings. That means our R2R ladder network is acting as a digital to analog converter. So here I am going to change the digits ABCD. The corresponding output voltage is going to be also changing, and it is well matching with the theoretically calculated values. So this is nothing but the formula which is used to calculate the corresponding output voltage of a R2R ladder network DAC. Then we have to define a quantity that is called as a resolution. So this is nothing but the formula for the resolution of a DAC, V divided by 2 to the power of n. So here I have selected the reference voltage V equal to 5 volts. So this is 5. N is nothing but bits. So in this demonstration I have constructed a 4-bit DAC. So that's why I have selected n equal to 4. So 5 divided by 2 to the power of 4, the corresponding value will be 0.3125. So this is called as resolution. Okay, the meaning of resolution is nothing but whenever there is a change in the input from one case to another case, nothing but there is a successive change in the input, the corresponding output voltage is incremented by a value that is called as the resolution, or you can say it is a step size. So here you can see when the input is nothing but all zeros, then case number 2 is nothing but it is set equal to 0001, the corresponding output is changing to 0.3125. Then the next case is nothing but 0. When the input is 0010, the corresponding output is going to be double. Then it is getting triple. Then it is getting 4 times, 5 times, 6 times, 7 times. So resolution is nothing but it is defined as the change in the output whenever there is a change in input from one case to another case. So that is called as resolution. So here, as per theory, the resolution is 0.3125. So here also we are getting the same value around 0.3125. So that is called as resolution. And one more thing, while constructing a DAC, so that is nothing but linearity. So this is nothing but the closeness between the variation of output analog voltage with the variation of corresponding input digital. So whenever there is a change in the input digital, simultaneously the output is also going to be changing. The change in output when compared to the change in input digital simultaneously, so that should be very matching.